Hi, everybody. In this video, I want to just do a very brief sort of reminder or introduction to bar and line graphs. We're going to do a ton of work with graphs in quite a few videos, and this is just kind of a quick introduction. I think most students are probably pretty familiar with a bar graph and basic graphs from other classes they've seen. I know these tend to start being brought into material even as young as like early elementary school. So I'm just going to do a very quick video here. If you want to take some notes off on the side, you can. Otherwise, I'm just using a couple examples from a textbook to talk these through. And of course, if you need more assistance with this, if this is not review for you, just let me know and reach out. So the first example you have here is a bar graph. And the reason we call it a bar graph is because these all look like bars, right? And they can go horizontally or they can go vertically as well. So you can see bar graphs done both ways. In this case, they're going horizontally. And there's actually lots of different variations of bar graphs. So for our purposes, you don't have to worry about all the different variations as long as you can recognize a bar graph, whether it's going horizontally or vertically, and you can read it, that's fine with me. But do know there's lots of different styles of these. So a bar graph consists of a series of bars arranged either vertically or horizontally. And then the example we're looking at here looks at worldwide internet users by region. So you can see along the axis here, you have the name of different regions of the world. And on the bottom here, it is labeled as internet users, and this is in millions. So for instance, this number 500 here is not really 500, it's 500 million users. Now with bar graphs, you could have numbers on both axes. You could have words on one of the axes, but typically at least one axis would be numbers to show you at least counts or frequencies or how many are in that group. But again, there's quite a variety here that could happen. Now, when you're reading it, this one is a horizontal. So let's say if I look at Asia for a second, I would follow that bar all the way to the end, and I would match it up with the number at the bottom. So it's a little bit bigger than this, but if I go right down here, I see that this very closely matches up with 2,500. Now it is slightly over. If you look carefully, it is just a little over. So perhaps the answer here would be maybe 2,550 million users or something like that. But you're looking at the end of that bar graph, whether it's horizontal or vertical, and just really matching it up with that axis to see the value there. For instance, if I look at Africa, again, I go to the end of that bar graph and I would scroll down. Now it's definitely a little bit more than 500, so you'll have to estimate. And you'll need to look at the tick marks on the axis. So notice here I have it labeled every 500. But there's actually a tick mark in between that's not labeled. So you'd have to use a little bit of reasoning there to figure out what that would be. Now, because it's halfway in between, what you could do is you could take the average of these two values, for instance, or again, you could trial and error and make sure it works. But if you look here, the halfway point between 0 and 500 would be 250. So this must be 250. And on axes, everything should be consistent within an axis. So if this tick mark here is 250, then I should be changing by 250 each time. So the next missing tick mark would be 500 plus 250, which is 750. And you can see that is the halfway point right in between. So again, your axes should always be consistent as we're counting. So in this case, if this mark is 750 and this one is 500, then maybe for Africa, we're at around, I don't know, maybe 600 or 575, something like that. So we just do our best to estimate. And of course, somewhere there actually is data for all this, right? So this graph is created from data. So you would actually have the actual count somewhere too. In this case, they don't give that to us. So we just have to estimate. So find the region that has the most internet users. And that's going to be the longest or the tallest if you're going vertically. So the most users would be Asia, right? If I scroll down here, it has over 2,500 million users. That is definitely the longest bar. And then the second question is how many more users are in the European region than in the Latin America, Caribbean region? So if I look at Europe, it's a little bit less than 750. And if I look at Latin America and the Caribbean, that is almost 500. Now, if you look at the solutions, this text does go into a little bit more detail there. So they're estimating the first one at 730. Again, it's a little bit less than 750. And they're estimating the second one at 470. So I think my estimates were more like 750 and 500, right? I knew I was a little bit off there. So you can be a little bit more precise. But if you're looking for the difference between the two groups, so how many more users are in one than the other, if you're looking for a difference there or a change, you would subtract those estimates. And again, if you don't actually have the numbers, you're just going to have to do the best that you can to estimate those values. Oh, that doesn't work. All right, let me do this. Okay. So one last example I want to talk about here. Let me see if I can just get a better, make this a little bit straighter for us. That's a little better. Is another style. So we're going to do a lot of work with line graphs, particularly in this course. But here's another example of a line graph. So most of the line graphs we do are going to just be one continuous straight line. As we get into more the algebra piece of it. But in the real world, you can have line graphs that look like this. So you actually have little line segments that are all connected. And these are useful in different cases. A lot of times we do use them with time. We're trying to show a trend over time. It's a very common graph to use where we plot our actual data and then we sort of connect the data points in between. But you can see that you have little line segments for all of these. Sometimes people will call it a broken line graph. Again, I hear just line graph more often, but they just mean broken line because you have little line segments in between all of these. Now, these are used when you have X and on your X and Y axis here. So your X axis runs this way and your Y axis runs this way, or your horizontal and vertical. They do both tend to be numbers. So these are typically used when you have like true points. So you have numbers on the x-axis and numbers on the y-axis. And we're going to talk about more points and all those other things as well. And then here you can see, so each of these circles is a point on that graph, and it represents a data point. And what happens is each of that point actually has two values to it. It has the value that matches up on the axis below, and it has the value that matches up on the axis to the left. So you can read it both directions, similar to how we read a bar graph, right? So for instance, how many milliliters of a drug are in the bloodstream at 5 hours? So in this case, I'm looking at the 5-hour mark. And what I can do is find it on the axis, kind of move my pen or my finger up to that point, and then I can see the point that works for 5 hours. And then what I do is I move across the other direction, and I see that that matches up with 60. So the answer here must be that 60 milligrams of a drug are in the bloodstream at 5 hours. At what time is the amount of milligrams in the blood the greatest? So greatest in this case would be the most, right? Obviously. So here our values go upward on the axis. So where is it the tallest? Well, it's the tallest right here, right? And that occurs at the 2-hour mark if I scroll down. When does the amount of milligrams in the bloodstream show the greatest change? Now, we're going to talk a lot more about change as well here on graphs. But in this case, you're looking really for where is it the steepest. Now, you really should do a little bit more math here to get a, well, sometimes to get an estimate if it's not clear. But for this particular graph, this one's pretty obvious. The steepest change is from 0 to 1, right? That is just really almost vertical. Not totally vertical, right? But it's much more vertical than any other place on the graph. And we talk about steepest too. We don't care about necessarily increasing or decreasing all the time, but just where is it the most vertical? So from 0 to 1 is where we see the steepest change. Right. So theoretically, if someone took a medication, for instance, they took it at the 0 hour, it's going to start kicking in pretty quickly. It's going to peak at the 2-hour mark, and then the effect of that medication and how much is still in the bloodstream is going to fade over time, right? So that's what we're seeing in the graph here.